Okay, so we've got a straightforward equilibrium question as the first part. So we have the supply and demand functions that are given in inverse form. So we need to set them equal to each other. Do we need to turn them into a different form where Q is a function of P to set them equal to each other? No, not necessarily, because remember, the definition of equilibrium is there's only one quantity and one price where the supply schedule or supply function is exactly equal to the demand function. So we could set the price of those two equations equal to each other or the quantity of those two equations equal to each other. It doesn't matter. So setting them equal to each other and then rearranging and solving for quantity. And I'm going to drop the superscript D and superscript S because in equilibrium they are going to be the same quantity. So it's just quantity. So we solve for Q, which is 1500. And in equilibrium, plugging that P back into either the supply or demand function gives us that. Okay, now let's orient ourselves to the next part of the question. What is the total surplus to consumers and producers? So they're asking for producer and consumer surplus. As a reminder, your consumer surplus is there and your producer surplus is there. What do we need in order to do that? We need to figure out exactly where that number is and exactly where that number is, the choke point for the demand curve and the choke point for the supply curve. And the strategy for both is just set the quantity demanded equal to 0 on the demand side, and that will give you this highest price on the demand curve right there. And on the supply side, you set the quantity supplied function equal to 0, and that will give you this choke point, lowest point on the supply curve right there. So for the demand choke point, you just plug in 0 to the demand equation. You get the highest price is 500. And the choke point for supply, using the supply function, I'm actually doing it the long way. You can just look at the y-intercept because in this case we're given the inverse demand and supply function, so we're given it in a form that's more like the y equals mx plus b. So that b is the y-intercept for both. All right, so now we have everything we need to solve for total surplus, which is the combination of consumer surplus and producer surplus. So we've got the height of that triangle, the width of that triangle, and the height of this triangle, and the width of that triangle. All right, and so your producer surplus is the same exact thing, right? Because it's a symmetric situation we have going on. Some of you may have realized that you can just take the area of that entire triangle in one fell swoop, which would be, of course, the area. So total surplus would be half base times height, and you have half of 1500. That's the width, and then the height is 300. That's going to give you the same thing, 225,000 to get to dollars altogether. And pause for just a beat and say, all right, can I explain what that represents? What does producer surplus represent in the market? And I would say something like it represents all of the gains to suppliers and consumers that exist because they were allowed to trade with each other. Right, all those consumers that were willing to pay more than 350 that didn't have to. They parted with dollars that gave them a lot of benefit, right? More benefit than they were expecting to get. Like something like they're getting more benefit by parting with those dollars than they are by holding on to the dollars. And from the producer side as well, they are parting with things that they're selling things that they're willing to accept a lot less than they actually have to. So they walk away richer also for the experience. Which is to say, this is basically some of the arguments for allowing free markets to happen. There is no greater total surplus than when you allow these voluntary trades to happen as much as they want at whatever price they want. Again, the caveat here is that this is assuming a well-functioning market, lots of competition, equal information on both sides, etc. Not very many markets are exactly perfect. Okay, how do we deal with a subsidy? Always remember that the subsidy, like a tax, will create a difference of the amount of that tax, or subsidy in this case, between the seller and buyer price. So the price that the seller receives in this case is $100 more than the price that the buyers pay. So since we're talking about the supply side, let's add that to the supply function. The price that's paid plus 100 is equal to, just plug in the supply function here. And simplifying, you get price equals 100 plus 0.1 Q, however you note it in the actual sapling, Q superscript S. For those of you curious, remember that this looks like an increase in the supply by the amount of that subsidy vertically. So we're asked to find the new equilibrium price and quantity. We should expect the new price to be lower and the new quantity to be higher. Let's see if it's true. We need to set the demand curve equal to the new supply curve to get our new equilibrium situation. All right, so here's our two functions, setting them equal to each other. So solving Q equilibrium, remember we can drop the supply and demand notation because they're equal in equilibrium. And you get quantities 2,000 and the price is 300. Last but not least, deadweight loss to society. Okay, so we need to figure out the new total surplus, which would be the area bounded there. Subtract the old total surplus, so that'll give us the change, and then also figure out the cost to taxpayers of the program. The missing piece of information for the new total surplus is the new choke point for the new supply curve, right, where that supply curve hits the y-axis. Sorry, I kind of drew this probably not to scale. That should be the quantity down there. Okay. All right, so we want to set the quantity supplied equal to 0 and plug it into that supply function, the new supply function right here. And we get a new choke point of 100. So this number right there is 100. So then it's just a matter of figuring out the area of that gigantic triangle. Let's go for it. All right, and we already figured out that the new equilibrium quantity would be 2,000, and the height of this triangle is the difference between 100 and 500. All right, so step one, our new total surplus is 400,000. So we'll need that, and we'll need our old total surplus, which we already calculated, and that was 225,000. Now what's the cost to taxpayers of the program? And the cost to taxpayers is $100 per each phone sold, and that is 2,000 phones sold. So that is a cost of 200,000. So we have a total surplus after the fact of 400,000. We had 225 before, so if you ignore the cost of the program, it looks like there's a gain of 175,000, but that program cost us 200,000, so the grand total is that we're worse, society as a whole is worse off after the program by $25,000. So the deadweight loss is 25,000. And we might say, without thinking too much about it, this program is not worth it. But that would be ignoring that there might be other goals of the program, equity goals, or there might be goals. This market may not have been a perfect market to start with. But anyway, that's going further than the question is asking us to go. So we have solved everything we minimally need to solve for the problem. Boom, there you go.